Welcome back for another set of notes. Today we are talking about 1.3 properties of functions. So I didn't feel like it was necessary to make a video on x and y intercepts, but if you have forgotten or think that you're wrong, please reach out and I will help you. All right, let's talk about symmetry and even and odd functions. So this is where we left off in 1.2 and we are picking right back up there. An even function is when some point on the graph has the point negative xy. So what does that mean? So if I had the point 1, 2, then that means that I must also have the point negative 1, 2, because I must also have what reflects across the y-axis. It also means that if I were to find f of negative x, I would just in turn get the original function at the end. An odd function, on the other hand, is if we have xy, then we should also have the point negative x, negative y. So if I had 1, 2, the point negative 1, negative 2 should also be on the graph. So looking at graphs, it's really easy to tell whether it is even or not, because if I were to look at the right half versus the left half, they should be symmetrical to each other to be even. This one is clearly not, so that means that it's not even. So now we're going to check if it's odd. Odd is kind of hard to tell about the origin. You got to think about half of the graph being rotated another half. Sometimes it's easier to think of it like, here is the point negative 2, 1. Okay, so to find, according to our what is odd, we have to have the reverse of that. So we have to have positive 2, negative 1. And sure enough, we do. Sorry if you hear my dogs in the background. And so therefore, this graph is odd. This one, I always like to see if it's even first. So does the left look like the right? And in this case, the answer is yes. So it is even. All right, what about this one? It is not even. I'm having some issues with my pen here and I'm not sure what's going on. Oh, maybe that's it. All right. And so it's not even, that's the easy one to look at. Odd would mean if this is at 3, 1, I should also have a point at negative 3, negative 1, which I do not. So therefore it is neither. What does this look like algebraically? So algebraically, you're going to test f of negative x. So that means where there's an x, you're going to put negative x. And in this example, what is the absolute value of negative x? It's the same thing as the absolute value of x. So therefore, it is even because that's the same function that we had originally. If I graph that, I would also see that it reflects. Next example. So I'm always trying f of negative x to figure it out. So where there was an x, I am putting a negative x. Again, negative x squared is negative x times negative x, which is positive x. Again, I have the same function, so again, it is even. Okay. What happens when I test f of negative x here? So notice there are 2 spots where there's an x, so both of those spots get replaced with negative. Negative x times negative x times negative x. Well, the negative times negative makes it positive, times negative again makes it negative, so I really get negative 2x cubed when I simplify. Same idea here, a negative times a negative is positive, so that's positive x. So this is the complete opposite. So signs and everything are opposite of the original function. Therefore, it is odd. And our last one, again, try negative x. We just talked about negative x cubed being the same as a negative on the outside x cubed. But this sign does not change. So one sign changed, but the other did not. So that is neither, because it has to be all or nothing. If it is not all or nothing, it is neither.